right? What we are attempting to do is to find the roots of an equation. So the first thing that we need to figure out, right? We're trying to estimate this without actually having to solve the function. Okay? The first thing we need to figure out is, does a root actually exist? You would recognize a root is where the function cuts the x-axis. Okay? So we need to figure out if a root, we're trying to like narrow it down. We're trying to play like forget it's called this game, right? But you have A here and you have B. We're trying to find exactly where the root is. So we're going to keep narrowing it down until we hit the root. That's okay? The objective is to hit the root. All right? So the first thing you want to figure out is there a root between 2 points? So for example, you might get a point A and you might get a point P. And the first thing that we have to do is to determine if a root actually exists in the middle lane. Any ideas what to do? Very good. What you will do is this. You will find f of A, so take A and drop it in there. Take B and drop it in there. And then take f of B, multiply it by f of A, and if a root exists, then this value positive and this negative, right? So if you multiply them, you will get something less than 0. Okay? That is called the intermediate value theorem. I will send you a more elaborate note, right? But for now, just call it IVT. Right? So what IVT says? IVT says that at least one root will exist if we multiply f of A and f of B and we get a sign change. Right? You're always looking for what? Sign change. Okay? That's very important. Every technique I'm going to show you today depends on this. Right? Isha, but you're using man. Right? Note that there must always be a sign change. There must always be a sign change for a root to exist. Right? Very important. There must be a sign change. Every time you find f of A and f of B, there must be a sign change. If the signs are the same, what does that mean? You don't have a root in the middle, right? So if they're both negative, means the 2 points down here. If they're both positive, means the 2 points up here. You don't want that. Okay? So there must be a sign change for a root to exist. Right? Sophia? You okay with that? I almost done. Yes, start with it. Yeah, you almost like pressure. Yeah, we know start. Yeah, miss nothing. That's all we do. We're just trying to find our roots. Okay? Right. Remember, there can also be a next root earlier. What you see, Adelia. So suppose this happened, Adelia, and suppose here is my A value and here is my B value. And I will still get a sign change. This value negative and this value positive. But it have more than one root, right? It have a root here, a root here, a root here. Right? That's why I say there must be for root. Okay. There must be a sign change for. Sorry, I should have said at least. At least one root to exist. I left it at least. Okay. How I could show one root exists? Isha. Yeah, using mark. How I could show just one root exists between here and here. Right? Would the function come back down if it have one root? Would the function going up here, right? would the function come back down if one root exists? And the answer is no. The function will just keep going up, right? Or the function will just keep going down. Okay? So to show one root exists, all you have to do is show that this is strictly increasing or strictly decreasing. How you do that, Cristiano? How you show something is a decreasing function or increasing function? How you show that? Very good. dy dx is less than 0. Here, dy dx is more than 0. Very good. You're using answer. All right. So what are the techniques? What are the techniques that we are going to use to find the roots? Right? Anybody remember them? Love it. I remember. Huh? Techniques to determine the root. Well, not determine, more to estimate, right? Yeah, first one is interval bisection. Very good. What's the next one? Adelia, any? None? Newton-Raphson. We'll do that last, right? Newton-Raphson. Linear interpolation. Okay, and then one more with the iterative formula, but it's a kind of Newton-Raphson technique. Yeah, make a formula, yes. So it's kind of you sometimes use the Newton-Raphson technique to get the interval, to get the iterative one, right? So these are the three techniques we're going to look at. Okay, I want to explain the techniques so we can take a look at them, right? I'll give you the formulas just now. The most popular is the first one. So I'm going to show to do it, right? Then I'll give you the formula for the others. Huh? Yeah. Yeah, I do one like it. They just give you an idea. They just tell you like two decimal place or put 3 decimal place. So like if it's two decimal place, you go to like 3 or 4. And when you see the first 2 decimal places being the same, it must be the same. Same number, yeah. So like if they want to reach like, so if you see like 2.5 and then you reach, sorry, 2.57, then you reach 2.58, these two are the same, yes. Right? And you would know if you're doing it right. You're getting closer and closer. The y value getting closer and closer to 0. Right? Because the root exists. The root exists when y is 0. Okay? All right. So I want to explain linear. I want to explain thing. Ready? So the same thing I just told Sophia, that note that the root alpha exists when y is equal to 0. I was not to watch it. You're going too bad now. I'll go and take it in. Not going too bad. I was doing good. All right. Ready? So I want to explain how bisection is going to work, and then we'll do an example. Linear interpolation is a formula, Newton-Raphson is a formula, so it's easy. We're just plugging in values over and over, right? But I want you to understand the concept of interval bisection. Ready? Watch it. So I want to explain the process of what we do, and then we're going to do an example, right? So let's say I gave you 2 values, A and B. The first thing that you are going to do, you are going to find f of A and you are going to find f of b. You will recognize that there's a sign change. That's okay? So if there's a sign change, you know the root somewhere there. The root not in the middle, right? Alpha could be here, alpha could be here. It don't matter. I just put mine in the middle. Right. So you see how far away they are? Interval bisection is trying to get closer and closer and closer until we reach the root. Okay? Or an approximation to the root. So after we find f of a and f of b, our next step is to find a plus b on 2. That will give us a new point, call that c. Then your next step, after you find c, is to find f of c. Right? What that will indicate is that will indicate where c is. Let's pretend c is a plus b. Let's pretend c is here. When you find f of c is going to be what? Positive, right? Yeah? So what will be the new interval where the root exists? Between a and c or between c and b? A and c. There must always be a sign change. You see that? So now we're between a and c. So now our step 3, we're going to find d, but we're no longer going to use a and b. We're using our new limits. We're going to use a and c. Are you okay with that? How I know to choose c and a is because if c positive, I must take the one that's negative. You must always have two values that have a different sign. Right, Javid? So now when I work out this, part 4, I find f of d. Let's pretend f of d is here. That's d. F of d is now negative. F of d turned out to be negative, right? So what do I use to find e? Do I choose a and d or d and c? D and c. And then you follow the process like that until you end up with a value that has an approximate based on the answer that they want. Right? Sometimes the question says do 4 iterations. So you're doing it 4 times. 1, 2, 3, 4 times. And the 4th one is the answer. Sometimes they say get the answer close to 2 decimal place. So you're working until they get the same thing close to 2 decimal places. But okay with that? Sometimes they'll take long. I mean, just 8 times. Okay? All right, we'll do a short one now. You got okay how to choose the new limits, the new boundaries, sorry. Right, so these are your steps, right? Right, linear interpolation, very similar, but it's a formula you're using. Okay? All right, let's try this one here now. Let's try this one here. Copy down fast. Couple plenty, para não falar glad to see it. Out update your father. All right, so let's go, right? So we want to use intermediate value theorem. So intermediate value theorem is this. They gave us the two limits, the two boundaries, 0 and 1. So plug in 0, plug in 1, tell me why again. Right? All we're interested in is a sign change, right? For now, they want 4 iterations, then special, then they didn't specify how many decimal places, so you can work in 2 decimal places for now. Okay? We just doing it 4 times and the next one 3 times. Right? So you just work out your answer to 2 decimal places. So first thing, find f of 0. F of 0 is 4e0 plus 2 by 0 minus 5. I get minus 5. I got f of 0 to be minus 5. What I get up? I get minus 1. You see what trick call it? Minus 1. So what trick call it there? Minus 1. Yeah, sorry, e to the 0 is 1. And then you find f of 1. What you all got for f of 1? 7.87. Nice. So is there a sign change? Yes. So you tell them f of 0 by f of 1 is less than 0. Therefore, by intermediate value theorem, a root x. A root exists. Good job, Olin. Now let's do 4 iterations. I want to go on the code, right? Right. Let's go on the board here and let's do the iterations, right? So I want to understand what we're doing. They said 4, so we just doing it 4 times, right? And I want you to see how much closer we get into alpha. I need to make it good. All right, nice. Question said 4 iteration. Is it the same function? Yeah. Question. Suppose they start right here. Oh yeah, suppose they start right here. Right? Suppose the question said do 4 iterations of this. Forget part 1. They didn't give it part 1. Do you just jump into the iterations? Yeah, you have to do IVT, right? You have to do IVT to show a root exists. Okay? Right. So how do we get the first iteration? Take the 2 boundaries, divided by 2, and you get a half. Right? Then go take calculator, find f of a half. We'll do that already. Right? There's a way to save the function. I just can't remember how to do it. Right? There's a way to save the function. Let's put the x value and press equal. So you gotta keep entering it now. Huh? Store and record. I can't. But you don't have there. Oh, you do it already? 2.094. 5. Right, we'll leave it right there. Nice. So Faith got 2.095. Right? So that value is positive. So what will the new boundaries be, Jacob? What do I take? 0.5 or 1.5 and 1? 1/2 and 0, because this positive and this negative. So we're taking 0.5. Right? That's our new boundary. You all recognize that we get a little bit closer to 0 compared to this one? This one was 7 point something. That's far from 0, right? And I got something closer here. So let's go to the second iteration now. The second iteration is 0 plus 1/2 divided by 2. That's a quarter. Find f of a quarter. How much? 0 point. You all see how much closer to 0 we got in Keshav? So Keshav, help me out now. What's the two boundaries we're using? Positive here. You always take the positive with the negative. So you're using 0 and quarter. Right? Do the next 2 iterations first. Easier. Right? These are things that you want to kill off in the exam, right? They are very easy. What is it doing on something? Hey, anybody, I want to sleep. You have to. There's such something. One substance then go. Yeah, I'll leave it here. So like when I do my test, I could always my calculator and use that now. Right. Next one, third iteration. You're okay with this? Tomorrow. Third iteration. What you got? 0 plus. Did I just say Tamara? Sorry. This is what 1/8, right? So what is f of 1/8? Sorry, Victoria. F of 1/8 is what? Yeah, that's okay. 0.46. Nice. So what will be any boundaries? What will be any boundaries? 4? It don't matter. Yeah. What you get here? Oh, by the way, earlier, when you're looking to see if the answer is getting closer, you're not looking at this, you're looking at the values in here. When you're on the top, right? Those values get closer. Yeah. Victoria, what we using? 1/8 and what? 1/8 and which one? And no, remember 0 negative. So it must be the negative and the last positive. That's okay? So it will be 1/8 and a quarter. Right? Because 1/8 was a negative value and a quarter is positive. What you told you? You all will recognize, right, Samara? You'll recognize that all these points here are negative. You recognize that? All these here are positive. So the negative always goes here. The positive always goes here. Right? That's 1, 2, 3. The fourth iteration now. Fourth iteration is what? Right? It will be 0 plus a quarter, sorry. I make a mistake, right? It should be a 1/8 plus a quarter divided by 2. How much is that? How much? A quarter plus a e divided by 2. And then 3/8, 3/16, right? And
Yeah.
f of 3/16 is what?
Excellent.
Negative 0.1048. This one is correct? Because what they're saying is that the quarter closer than this. So now let me the other way around. Unless you make a mistake here. Too late. Which one? No, I'm talking about this one. Right, so our final answer that we go in with for alpha is 3/16. Right? That's where you stop after the fourth iteration. Okay? Everybody got this? No, what you got? 261. Right? The reason why we can identify that a little bit off is because our fourth iteration should be closer to 0 than the others. Right? If we do a fifth and a sixth and a seventh iteration, it will be much closer. That's okay? Right. And remember you're comparing these two values, huh? So for example, was it the decimal for this again? 0.125. And this is 0.25. What about here? Was it decimal for 3/16?
0.18.
1875. And here is still, I will have to choose a quarter. So the value is getting closer and closer. Okay? Right? But they didn't ask it like that. But if they ask like that, the two decimal place, you have to keep rounding off until these two are the same. Okay? Right, let's take a look at linear interpolation now. Right, same principle. The difference is instead of using this, we're using our next formula. Okay? Oh wait, let us find this slide with all the techniques. We will write it down and take a picture now. No, look at that taking picture. There's the formula for linear interpolation, there's the formula for Newton-Raphson. Watch this all here. That there's differentiation, F prime, right? Take a picture on this, take a picture on this. There you go. Oh yeah, write down the linear interpolation formula. What do the two lines there mean again, Olia? What do the two lines mean? Modulus, right? So it means that you're not taking the, you're ignoring the negative sign. You're taking the positive value only. Everybody have that? Right? Do the interpolation here. Pull off. Wait. Pull off on that. Let's do the interpolation from the last one. Did I lose it? I lost it. What was the function earlier? Oh, 4E. Let's do part 3 now of this same function. Right. Let me explain linear interpolation. What's here earlier? Linear interpolation is just like interval bisection, except instead of using the bisecting the middle point, we're using this. This is the formula that we're using here. That's the formula that we're using here instead. Are you okay with that? No? So, how do we get our first iteration? To get the first iteration, we're going to use the formula B by the modulus of f of A plus A by the modulus of f of B all over the modulus of f of A plus the modulus of f of B. Right? So we're using these two values, right? We're starting over. Right? So A is equal to 0, B is 1. Alright? You happy? A is 0 and B is 1. So it's 1 by the modulus of this. Modulus of f of A is -1, so I'll put in +1. A is 0 by f of B. F of B is 7.87. Right? So it didn't specify anything, right? Right? So we'll stick to what? Again, if you're plugging this formula, it's just to keep pressing equal to get the iterations. Right? But you still have to show the work. You might know what to get. F of A is 1, f of B is 7.87. Right? Work out this, and that will give you your first iteration. How much is this? What is this? Okay, maybe it's like 2 or 3 decimals later. (0.113). Right now, we have to find f of 0.113. Right? And then we have to decide what the new boundaries are. Push-ups. Why is the word change? Not error, buddy. Yeah, but that. Do my favor. Just do my favor there. Plug in -2 and -1 there and see what you get. Normally it's we continue with the same bar. It don't matter, you can keep, it don't matter how supplier, it don't matter how close the boundary, you can keep going and work until that boundary. Plug in -2 and -1. That can probably get error. When you plug in -2, what you get? 3 point, and then plug in -1. That'll be -2. Positive 2.
What is? You just want to know.
Okay. Alright, don't worry, let's just do 0 and 1 and do about 2 or 3 iterations. Use 0 and 1. Forget that. Right? Normally just give it the same thing. So -2 and -1 also intervals. Okay. Continue. So what you got here? F of 0.113. -0.49. So like we'll go with 4.6, right? Nice. Watch this here. So which one, what will be our new intervals? What will be our new intervals? Negative always goes here. And the positive will go here. Okay? So we go again. Find x2. Find x2. Right? These are your, this is now your A and this is now your B. Hurry up. Find your A and B. Hurry up. Find the next 2 iterations. So that's right. They want you to use -2 and. But we do have. Right. Right. You all done? I'm still not gonna do it there. Right, so your second iteration will be B. B is 1, f of A was 0.496. A is 0.113. And then f of 1 was huh? No minus, no minus modulo. Right? At least you're trying to understand. Yeah. At least you're trying to understand it. Right? Where you get for x2? Where you get for x2? Huh? What? How much you get for x2 Adelia? Go away with them. 0 point? 0.16. Yeah? 165, okay. 0.165. We getting any closer? We can't tell yet. Find f of 0.165. How much you got? What f of 0.165? I know. Anything? Yeah? Okay. So this question is not hard, it just take time to put in the calculator and work it out, right? I got 1.652. Victoria? How much you got? I'm going to get back. Because the formula is modulus.
Oh.
They never use the negative value. Nothing? Okay, but that's probably why they say to use minus 2 so what? Yeah, that's my fault for trying this. Right? Really and truly, they didn't say to use 0, 1. They said to use minus 2, minus 1. All right, anyway, but you'll follow. So here, invalid. Right? So that's the reason why they told to use here. It appears that the function is not defined as it gets. Why it's not defined for here though? All right, so that's probably why they want us to do it like this, right? All right, wait. Way out. Which one? Minus 1, minus 1. Yeah, and that's what it is. What you getting? Yeah, try it and see. So that's the only reason why they told us to use f of minus 2 and f of. Huh? Does have a solution? Oh, that's what I want to. Anybody can graph it? You don't know how to use the graphing? No? You actually have a program that he's used Geo. Yeah, just plug that function in. I want to see it. Yeah. How much you got? Minus 0.2. Right. 228. Right? So we can keep going. What will be our new boundaries? Our new boundaries will be 0.165 and the last value is which one positive again? 1. Oh, you know why they leave it out? The reason why they change it is because it's not converging on the right side. It only converging here, so it will take longer. Okay? Okay, I know what the function look like now. All right, but do you allocate how to use linear interpolation? Yeah? Yeah? Okay, so remember, we're using modulus, so no negative values, right? Keshav? No negative values. Okay? Let's try the last one, Newton-Raphson. Newton-Raphson is the easiest one. I love Newton-Raphson. You any problem with Newton-Raphson? You any problem with Newton-Raphson? Is you have to remember to differentiate, right? Last one, head of Newton-Raphson. Right, just write down the function, just write this down now. Write down the function. Charlie, Charlie. Right, they said x1 is 1. G of x is e to the 4x minus 3 minus 4 between 1 and 2. Give your answer to 3 decimal places. And they said to do 2 iterations, right? All right. Ready? So how do we get, they told us x1 is equal to 1. How do we get x2? The formula for x2 is what? x1 minus f of x1 all over f prime x1. We know x1 is 1. This formula, I think it's given to you in the formula sheet as well. I think they'll give you the Newton-Raphson formula, right? This formula, just like the linear interpolation, it allows you to get closer and closer to your root. So first thing, let's find it here first. x1 is 1. Let's find f of 1. So plug it in here. E to the 4 by 1 minus 3 is minus 4. This is e to the 1 minus 4. How much is that? 3 decimal places we're working with, right? So when they say 3, let's write all our answers 4 decimal place and then round it off later on, right? We don't want to start rounding up too early. E to the power of 1 is what? Minus 4. How much is this? Minus
1.
That's it? 2? Anymore? No? 4 decimal places. Yeah, because you don't want to do the conversion too early. So minus 2.8. Nice. Let's find f prime first. How is differentiate this all here? What's the differential of this? The differentiated power, the differential of 4x minus 3 is 4. Then you write back 4x minus 3. Differential of minus 4 is 0. So that is our differential, right? So we have to find g prime 1, right? So that'll be 4e to the 4 by 1 minus 3. So that's 4e to the 1. How much is that? Ten point. That's it. Exact. Right. Let's take the 4 decimal places for now, right? We are round it off after. Didn't make a big difference now. I mean. Right, now put in the calculator. That's 1 minus g of 1 is minus 1.2817. G prime is 10.8731. Give me the answer, 3 decimal places. Work out this. 3 decimal places.
1.117.
1.117.
1.18.
That's okay? Right, where we starting now, Faith? How we getting x3 now? Oh, what? What's the right? Right, back the formula again. X2 minus X2 all over. So we know what X2 is, right? 1.118. Right? We have to find G of 1.118. That's e to the 4 by 1.118 minus 3 minus 4. And then find G prime 1.118, which is 4e. Send me the answer. Work it out. How many iterations? 2, right? Just 2 iterations. So we stop in there and then do the next one. Oh yeah, that's why iteration. I want to do one more. Go ahead. Oh, yeah, remember the -4. Remember you have to work out this, huh? Remember you have to work out this and then -4. Right? And then -4. This one here, just to put it in the calculator like that. All this is in power. What you all got for this one? 0 point. Anybody got that? 0.3579. Next one. Positive 0.3579. And this one is what? 17.18. So now x3 X3 will be X2, which is 1.118 minus 0.3579 over a small value, right? So it shouldn't change it much. Okay, you shouldn't get something less than 1. The answer should be between 1 and 9. How much you got here? 0.9. Yeah. Okay. That's the way you use Newton-Raphson. All right. I told you I wanted to stop a little today. Right, I want to run out. Huh? I like game and two, and that's for Papa 6. I can make it out. I just had to sit down till halftime.